Modern technologies such as AESA radar, beamforming, and MIMO require the need for wide bandwidth, phase-coherent multi-channel analysis. The oscilloscope is an ideal instrument designed specifically for wide bandwidths and phase coherency with multi-channel analysis and controls. Hi, my name is Dylan Stinson. In this video, I'll be showcasing the DPO 70000SX oscilloscope with the new SignalView VSA software version 5.3 with multi-channel analysis support. And we'll be using the pulse analysis plugin, including fast frame support, to show a typical example of validating a MIMO phased array radar. For today's demonstration, we have a 2-channel AWG 70000 simulating the 2 signal beams from our MIMO phased array radar system. And those 2 channels are connected to the 2 channels of our DPO 70000SX oscilloscope. The DPO 70000SX oscilloscope allows for analysis on up to 4 channels simultaneously and up to 70 GHz in frequency and analysis bandwidth. To begin, let's first go over the basics of MIMO radar, understand the distinctions from AESA radar, and then understand the challenges of validation and testing of these systems. An AESA radar operates in 2 modes, scanning and tracking. In the scanning mode, it steers the radar beam across the field of view in search of a target. This beam steering is achieved by manipulating the phase and amplitude of each transmit-receive module. While an AESA radar can generate multiple beams to swiftly survey the field of view, this approach impacts the transmit gain, consequently affecting the range. Once a target is detected, the AESA radar locks onto it and continuously tracks its movement. However, even when utilizing multiple beams created using subarrays, the AESA radar still takes time to cover the entire field of view. Elements in a MIMO radar system, on the other hand, operate independently and collectively cover the entire 180-degree field of view without the need for directivity adjustments. This significantly improves scan times. The MIMO radar employs time, frequency, or coding techniques in each transmit signal to differentiate them in the receiver element to extract target properties. To acquire the signals, which may have different center frequencies, time slots, or modulation parameters, the multi-channel wideband test system needs to be capable of independent settings for parameters such as center frequency, span, and RBW. The TDM MIMO radar assigns a time slot for each element. The signal on each channel has a pulse width of 1 microsecond and PRI of 100 microseconds, and slot delay between channel 1 and channel 2 is 10 microseconds. Let's use SignalView to see whether the signals generated are aligned correctly to the assigned time slot or not. To do so, we'll set up SignalView to capture on both channels using the spectrum display. The source can be connected to any channel, math, or reference channel from the oscilloscope. This helps us in applying filters or performing complex operations before analyzing in SignalView. Additionally, the signals can be RF, IQ, or differential IQ pairs. We now will launch the time overview display to assist us in configuring the analysis time and spectrum time parameters. Time overview is configured in such a way that it acquires at least 5 to 6 pulses for analysis. Let's examine the starting position or the start time of the pulses on each channel to determine the time delay between them. Additionally, let's measure the PRI of both channels to determine if this delay is consistently maintained or not. To automatically measure the pulse time or position of each channel, we can launch the pulse table, which provides up to 31 pulse parameter measurements for each individual pulse. The time measurement within the pulse table will display the starting time for each pulse. In addition to this, let's enable the PRI measurement. a difference of 10 microseconds can be easily seen in the pulse table. You can also observe the time trend and measurement statistics using the pulse statistics display. With this display, you can see how the PRI varies across pulses over time. The pulse table provides information about the absolute delay between channels, or time slot, while the time trend reveals how this delay is maintained over time. Currently, we are acquiring only 5 to 10 pulses, but to gain a comprehensive understanding, we need to analyze over many pulses. We can use the cumulative statistics display to get statistics for these measurements over multiple acquisitions. However, the scope's record length determines how long a signal can be captured. In this scenario, most of the acquisition's time is dedicated to the pulse-off period, when our primary interest lies in the pulse-on period. Fortunately, SignalView's fast frame mode on scope allows us to capture only the pulse-on time while disregarding the pulse-off time. This innovative method greatly facilitates the analysis of hundreds of pulses without compromising the quality of our analysis. It divides the memory into smaller segments and fills the segments with only the on-time data while preserving the timescale information. For improved signal visualization in fast frame mode, the pulsogram display is a valuable tool. It allows us to create time versus time and frequency versus time plots for these signals, making it easier to detect any instances where a pulse deviates from its assigned time slot. The combination of automatic pulse measurements and fast frame segmented memory capture, along with independent controls, allows us to analyze intricate scenarios such as MIMO radar. The pulse analysis can be executed concurrently across multiple channels. The advanced pulse analysis package offers up to 31 measurements to automatically characterize the pulse sequences. For MIMO radar, the signals are orthogonal for utilizing distinct center frequencies for each element. Therefore, center frequencies for each channel in SignalView needs to be configured independently. Settings such as center frequency, span, and RBW for each channel can be adjusted independently. This capability allows us to effectively analyze wide bandwidth multi-channel phase synchronous systems operating at different frequencies using SignalView. Having fully configurable and customizable controls in a multi-channel wide bandwidth analysis solution allows you to address even the most complex of scenarios. Tight synchronization of multiple instruments using the UltraSync architecture provides configuration flexibility, allowing you to easily add acquisition channels and maintain channel-to-channel timing accuracy. Greater than 4 channels can be acquired and analyzed through a combination of programmatic control and separate instances of SignalView software running on each instrument. In this video, we showed you how you can gain a thorough understanding of a typical MIMO phased array radar system. SignalView version 5.3 now supports multi-channel analysis for enabling phase-coherent analysis of multiple signals simultaneously. Combined with the DPO-70000SX oscilloscope and fast-frame segmented memory capture, you can quickly analyze minute changes over thousands of pulses, over multiple channels, over time and frequency domains. For more information on Tektronix's multi-channel RF test solutions, visit the SignalView product pages on tech.com or contact your Tektronix account manager.